Okay, Assalamualaikum. So I'm Dr. Wanu Shahida. Okay, I will explain the whole chapter 6 for the applied statistic. Okay, so chapter 6 here, it is a last chapter for the applied statistic. Okay, so we have goodness of fit and contingency table. Okay. Okay. So for the contents, we have about two main subtopic here. Okay, the first one is a goodness of fit task. So under this, we have another two subtopic. Okay, the first one, goodness of fit for the categorical data, and then we have fitting of the distribution. Okay. And the second subtopic, we have the contingency table, testing for the independence between two variables. The first one, and the second one is a test homogeneity proportion. Okay, and the third one, it is for the Microsoft Excel, how to get those values from Microsoft Excel. So the third one here, I leave it to you. You can study from the slide and also from the note in module. Okay, so I will focus on the 6.2 and also 6.1 and also 6.2 lah. Okay, for this chapter. Okay, so the idea of the chapter 6, okay, you are dealing with the qualitative data. Okay, so this chapter 6, it is specifically for the qualitative data. So the data that you have here, it is a frequency data. Okay, so I think we have explained before this. Okay, when we have qualitative data, qualitative variable, the data that you get, it is a frequency data. So it is similar when you discuss the proportion. Proportion, it is for the qualitative variable or qualitative data lah. Okay, the data that you have, the number that you have, it is a frequency. So similar to here. Okay, what you have here is a frequency data because the variable here is a qualitative variable. Okay. Okay, the objective of this chapter, okay, by the end of this chapter, you should be able to test the goodness of fit for categorical data, test whether the categorical data fit to the certain distribution, such as binomial, Poisson, and normal. So these two, it is for the 6.1 and these two for the 6.2. So use a contingency table to test for the independence and homogeneity of the proportion. It is 6.2. Okay, sorry. And the last one here for the 6.3, use Microsoft Excel to solve goodness of fit test and independent test. So I will not go to the Microsoft Excel. Okay, I will focus to the 6.1 and 6.2. Okay, for the Microsoft Excel, you already know the features of the Microsoft Excel, so you can study by your own. Okay, how to use Microsoft Excel to get the value that you want for the goodness of fit test and also for the contingency table here. Okay. Okay, the example of the qualitative variable. For example, the type of the juice preferred by UMP student. Okay, so amount of time spent by UMP student to sleep daily. Okay, so this one, even though we have the amount of time here, we can change into the qualitative variable. For example, the usual time or the common time is a 6 hours. So 6 hours, how many students? Okay, for the 6 hour time spent, how many students? So the number of students sleep for the 6 hour, that one is a frequency data lah. So we can change to the qualitative research here or qualitative variable. Okay, PM student satisfaction towards the service provided at the library, I think should be UMP or UPM. It is similar lah. Okay, so satisfaction, it is clear, it is a qualitative data, and country origin of the UMP student, so it is very clear that it is a qualitative data. You have like Malaysia, you have like Yemen and so on. Okay, so and then how many students from Malaysia, how many students from Yemen, how many students from China. So the data that we have here, it is a frequency data. Okay, so you can apply this statistical analysis for that kind of data. Okay, so we go to the 6.1, the goodness of fit task. Okay, or the short form is GOF. Okay, goodness of fit task. Okay, or sometimes I just call it is a GOF lah. Okay, GOF. Okay, so the lesson outcome for the 6.1. Okay, so by the end of this topic, you should be able to apply the goodness of fit task for categorical data. Test the data whether fit to the binomial, Poisson or normal distribution. This is the 3 common distribution that we have that we study in this course. Okay, we are not go to in detail to the binomial, Poisson and normal distribution. Okay, what we want to see here, what we want to determine whether the data that we have fit to the binomial or Poisson or normal or not. Okay, by using goodness of fit task. Okay, and okay, that one later lah. Okay, so 6.1.1 we have goodness of fit task for categorical data. Okay, the test is applied when you have one observed variable from a single population that can be categorized. It can be used if there are more than 2 categories. Okay, so this is a condition of your data. So you have one observed variable from a single population. For example, the type of juice. Okay, from the previous example, the type of juice. Okay, so you have to make sure the data that you get, the frequency that you get from similar population lah. If you are talking about your MP, then the data from your MP student, okay, that can be categorized. So type of juice, it can be categorized. So we have many type of juice, and it must be more than 2 category. Okay, must be more than 2 category. So we have type A, B, C, D, and so on. If you have single category or you have 2 category, you can use a statistical analysis from the chapter 3, which is test hypothesis for the proportion, because what we have here is a qualitative data. Okay, so chi-square will be used in goodness of fit. Okay, so for the whole chapter 6 here, okay, you are dealing with the chi-square distribution only. Okay, only the chi-square distribution. Okay, so it's used in goodness of fit to compare the observed frequency in the sample with the expected frequency. Okay, observed frequency, the real data that you get. Okay, the real data that you collect. Okay, the data that we collect. So so means that here the data in your question, it is a observed frequency. Okay, the data that we collect, the real data that we collect, it is an observed frequency. Expected frequency, what do we expect based on the given distribution of your data? Okay, expected frequency, what do we expect based on the distribution of the data? So what you are going to calculate is an expected frequency, observed frequency given in your question. Expected frequency, we will calculate based on the distribution of your data. Okay, so the frequency obtained from the actual performance are called observed frequency. So means that the real data that we collect or the data is in your question, it is an observed frequency. So notation that we use here is a OI. Why? The frequency that we expect to obtain are called the expected frequency. Okay, so this is what we expect. So based on the distribution of the data. Okay, so notation that we have here, EI. So the goodness of fit here, we compare between the observed frequency and expected frequency. Okay, So basically the value of the expected frequency is calculated based upon the claim distribution. So the expected frequency here we calculate based on the distribution of our data. Okay, so to be easy, like if you have Poisson, normal and binomial, so we calculate based on that distribution when we have Poisson, when we have normal, or when we have binomial distribution. Okay, so we have specific formula that we use to calculate the expected frequency here. Okay. Okay, so we have the assumptions for the goodness of fit. So the chi-square GOF task is appropriate when the following assumptions are satisfied. The data are obtained from a random sample. The variable under study is a categorical data and the data is an observed frequency. Okay, so 1, 2, 3 for the learning purpose, we assume that it has been they has been fulfilled. Okay, for the learning purpose, we assume that the data that we get from that question, okay, already fulfill this assumption. But the number 4 here we have to check. Okay, the expected frequency for each category must be at least 5. If the expected frequency less than 5, combine the adjacent category. So this one I will explain later. But the fourth, but you have to know that the fourth assumptions here we have to check when we do the analysis, when we do the calculation. Okay, 1, 2, 3 we assume that already fulfill for the learning purpose. Okay. But this one, okay, the variable under study is a categorical data, so you have to make sure the data is a categorical data. So categorical data is a qualitative data lah. Okay, the data that you have here must be frequency data. Okay. So when to use GOF? Okay, so we have two condition here when we use the GOF. First, to compare between the observed and expected frequency for a certain categorical data. So we are talking about the 6.1.1. Okay. And second, to determine either the observed frequency for an experiment follow a certain pattern or distribution. So we have binomial, Poisson, and normal distribution. Okay. So the 6.1.1 we try to compare the observed and expected frequency for a certain categorical data. For the 6.1.2, we try to determine whether the data given followed a certain pattern or distribution or not. Okay, so we have this example lah. Okay. Okay, so the task statistic for the goodness of fit, task for the categorical data. Okay. So similar formula for 6.1 means that for the 6.1.1 and also 6.1.2 we have similar formula to find your chi-square. So O here is an observed frequency, E here expected frequency, the K here represent number of category, and the degree of freedom for the chi-square distribution, your critical value, it is K minus 1. Okay, so how to calculate the E here? So E is a NPI. So N is a sample size. Okay, the sample size. PI probability. Okay, for I, for each category lah, because I represent category here. K is a number category. So PI probability for each category. So how do we find the probability? Based on, it is based on the distribution of your data set. Okay, so I will show later how to calculate the probability for the 6.1.1. Okay. Okay, so for the hypothesis, okay, so because of the goodness of fit test here, it is still hypothesis testing. So the steps similar we have from step 1 until step 5. Okay, so the first step similar, we have to formulate the hypothesis. Okay, if you discussing the goodness of fit test, we have same pattern of hypothesis testing. We have same pattern of hypothesis. Okay, your null always be there is no different, there is no change, there is no preference. Okay, H1 there is a different, or there is a change, or there is a preference. Okay, so null here means that there is no difference between observed and expected frequency lah. That's what we meant. Okay, and here H1 there is a difference between them. Okay, or you just state the claim of the categorical distribution at your null. Okay, what is the claim from the question? We state as a null. So H1, the categorical distribution, is not the same as stated in the null hypothesis. So H1 similar, it will be contradict to what you state at the null. So null, you state the claim, or you can state that there is no different, there is no change. Okay, H1 there is a different. Okay, so we go to the the example letter. Okay, then you can see now how we formulate the hypothesis. Okay, so because of the hypothesis testing, so you will have this 5 steps. Okay, so the step 1 is formulate the hypothesis. Step 2, we compute the chi-square task. Step 3, find the critical value. So for the goodness of fit test, we are dealing with the right tail test only. Okay, there's a behind derivation while we have the right tail test only here. Okay, so it is related to the okay, so also related to the chi-square is a positive distribution lah. Okay, so it will be always right tail test, doesn't matter what hypothesis that you have here. Okay, it will be always right tail test. So the critical value here, it is based on right tail test. So then you will have chi-square alpha k minus 1 as your degree of freedom. So step 4, decision. So decision, we are discussing what happened to the null, whether you are reject null, whether you do not reject null. So decision here we make based on the right tail test. If your chi-square test greater than critical value here, then reject null. If the chi-square test less than critical value, then do not reject null. So step 5, draw a conclusion to reject or accept the claim. Okay. So as you know, step 5, we discuss what happened to the claim, whether you reject the claim or whether you accept the claim. Or you can write here which hypothesis that you support. If you reject null means that you support H1, then you can write the statement of the H1 here at your conclusion. If you do not reject null means that we accept null. Okay, so you can write the statement of null here. Okay, so you can write the statement of null at your conclusion. Okay, or you can discuss what happened to claim lah. Okay, so claim always be at null here. Okay, so why the test is called goodness of fit? If the graph between observed value and expected value is fitted, one can see whether the value are close together or far together lah, or far apart. Okay, so means that here if we sketch the graph between observed value, the data from the actual performance, and also the expected value, the data that we calculate, then we can see whether those values close together or it is far apart. Okay, so the test is called a goodness of fit test because the hypothesis tests how well the observed frequency fit a given distribution. Okay, so this is meant for the 6.1.2. So when the observed value and expected value are close together, okay, means that you will have a good fit. That's why we call it as a goodness of fit task. We need to see when we compare between observed and expected value, we have a good fit or we have a not a good fit. Okay, that's why the task is called goodness of fit task. Okay, so if the observed value and expected value are close together, then it is a good fit. If you sketch, then you will have this figure, this environment. Okay, so how we know they are close together? When the chi-square test value will be small. When we have small value of the chi-square, but we do not have range of the value for the chi-square to say that it is a small value. So we know that we have small value when decision in start 4 is do not reject H0. So when do not reject H0, then what I say just now means that do not reject H0 means that there is no difference between actual performance and expected performance. Okay, there's no difference between observed frequency and also expected frequency. Okay, so when you do not reject H0 means that we have chi-square small. Okay, we have small value of the chi-square, then we have a good fit. Okay, we have a good fit here. Okay, so a good fit, it is when observed value and expected value are close together. Okay, if the observed value expected value are far apart, so if you sketch, then you will have this kind of the environment. Okay, they are far from each other. Okay, then we have a not a good fit data. Okay, not a good fit data. Okay, so how we know they are far from each other? Okay, when we have large value of the chi-square test. So how we know that we have large value? When decision is reject H0. So when decision is reject H0, decision in start 4 reject H0 means that there's a difference between the observed value and expected value. Then we have a not a good fit data. Okay, for this example, I will explain in detail how to solve, and hopefully you can use this example to solve your exercise question. Okay, so that's all for the first part of the chapter 6 here, the first part of the 6.1.1. Okay, the second video, it is about example 6.1. Okay, thank you.